We are now on our last part of the problem, in which the part 4 is consists of 4 problems, and we are just tasked to identify the C flag, or examine the C flag of the given code. So let's create a new project. Select Atmel AVR Assembler, and we will rename this project as Activity 4, since this is our last activity. We will change I have mistaken with the name. Let's change it to I, and then let's change the path of the file. And previously it was activity 3. Let's move it to activity 4. Press OK, and then click next. And then we will choose our device platform. We will debug platform. We will use AVR simulator, and our device is at Mega 32. And then click finish, and let's wait for the IDE to load. And since this is our IDE, I will just type in the code. We are given the code, obviously, and just look at the description below to see what are the codes that is given to us to examine with the C flag, as well as the register. So I will just type in the code. And since it is just 3 lines of codes, we can now proceed with the assembling of the codes for us to verify if there are errors. Since we did not encounter any errors, we can now proceed with the debugging mode by clicking the assemble and run command. Let's wait for the IDE to load, since I am simulating this using the mobile version. And here we are in the debugging mode. We will use the single step to examine the C flag in the status register. And for the first 2 loading of values, there are no changes, but after the add instruction, there are changes with our flags. As we can see that the sign, overflow, and the C flag has been turned on, meaning that the addition of R20 and R21 values has exceeded the 8-bit of the status register, or it exceeded the D7 bits. So let's try to reset this one, and we will try to examine the registers to see if we are going to load the values and perform the add instruction. For the first single step, we had loaded the 85, the 92, and after the adding of the values, we can obviously see that the value of R20 has been changed. And I think that's for the first problem. Let's proceed with the second one. In this part, I did not even create a new file. However, I just re-edit the codes, change the values and the name of the registers to reduce time consuming. And again, just look at the description to see what are the given codes to us and to examine the C flag. Now I am done with the writing of our code. Let's try to assemble to see if there are errors within this code, or there are no errors. And fortunately, there are no errors, so we can now enter in the debugging mode by pressing the assemble and run. And let's just wait. Now we are in the debugging mode. Let's try to examine the flags, specifically the C flag with a single step. And after loading and adding the values, our flags has set to turn on the overflow flag and the negative flag, but our C flag has been turned off, since maybe the resulting value after adding the R16 and R17 does not exceed the 8-bit register. Now let's reset the debugging mode and for us to verify or examine the registers as well as the loading of values. And using the single step, as we go on with the loading of values, it is obviously that we had successfully loaded the values, and after the add instruction, we had successfully add the hexadecimal values on our registers. And then we will proceed with our third problem, wherein I did not create any file again. I just do some editing of the codes, since it will save much more time of work. Just kindly see the code on the description below. After writing the code, we can now proceed with the assembling of the codes, wherein it will help us to verify if there are errors within the code. Fortunately, there are no errors, so we can now proceed with the debugging mode by clicking the assemble and run button or icon. Let's wait for the IDE to load. And now we are on the debugging mode. We will just examine the flag, specifically the C flag, with the help of the single step. Jumping over with the add instruction, the carry flag has been turned on, meaning that the addition of R25 and R26 values has exceeded these 7 bits, or it exceeded the 8-bit register value. So now let's reset this operation for us to view or examine the registers using the single step. As we step with the instructions, we are successfully loading the values, and after the add instruction, the value of R25 has successfully changed from the fixed value of F5 down to 0x47. Without any further ado, let's proceed with the fourth problem, in which I did not create again a file. I just rewrite the code, and it will reduce much time of my work. So if you want to see the problem, just look at the description below. Now that I am done with the writing of the code, let's proceed with the assemble for us to verify if there are errors or there are errors within this code. And fortunately, we did not encounter any errors. So we can now proceed with the debugging mode by clicking the assemble and run icon. And now we are in the debugging mode. Let's try to examine the flag after the single step method. We are successful with our first load instruction, but after the first increment instruction, the flags N and S has been changed from 0 to 1, but the C flag has not changed, meaning that the increment of R25 is not exceeding the 8-bit register. But as we go on with the next increment instruction, the Z flag has been turned on, meaning that the resulting value of the previous instruction has been equal to 0, meaning it will be equal to 1 of our Z flag in the status register. So we can now reset this one and examine the registers if there are changes with our values successfully with the help of single step. If we look on the left side of the IDE with the status registers, the values has been changing from FE to FF and then to 00, meaning that the value of R25 is incrementing twice. And I guess that's it. Thank you for watching this video.